Hi, hello dear students, welcome to our channel. In this video, we are discussing about multinomial theorem and the applications, two examples or two or three examples we will discuss now. Exclusive for this type of questions they will ask in JEE mains or advance. So what is the multinomial theorem? So here in the multinomial theorem we have binomial theorem means it contains only two terms. The power will be n. Similarly, if n be a positive integer, n be a positive integer, then observe carefully dear students, x1 plus x2 plus x3 plus and so on plus xk. So generally binomial means only two terms. Trinomial means three terms, but here k terms are there. That means multinomial whole power n is equal to x1 plus x2 plus x3 plus and so on xk plus xk whole power n is equal to sigma, the whole power n is there, no, n factorial divided by here the product of here x1 x2 x3 and so on xk is there, no. So for each and every term n1 n2, that means n1 suffix, that also 1 is the suffix, n1 factorial, like this n2 factorial, like this n3 factorial and so on into nk factorial into x1 power n1 into x2 power n2, x3 power n3 and so on xk power nk. This is the way we can express the multinomial expansion. See, x1 plus x2 plus x3 plus and so on xk whole power n can be written as summation or sigma n factorial by n1, the product of k terms, n1 factorial into n2 factorial into n3 factorial into and so on nk factorial into x1 power n1, x2 power n2 and so on xk power nk, where this is the important thing, n1 comma n2 comma n3 comma and so on nk are non-negative integers or non-negative integers subject to, this is very important condition, subject to the sum of these values n1 plus n2 plus n3 plus and so on nk is equal to the power of multinomial expansion is equal to n. Then only it will be applicable, subject to n1 plus n2 plus n3 plus and so on plus nk is equal to n. So in this the number of terms in the expansion, how to calculate? Generally, x plus y whole power n means this expansion, binomial expansion, contains n plus 1 terms. Next, the number of terms in the expansion in the expansion of x1 plus x2 plus x3 plus and so on xk whole power n, or the number of terms n plus k minus 1 c k minus 1, or we know that NCR is equal to NC n minus r, no? So where n is equal to n plus k minus 1 here, and r is k minus 1. So NC n minus r, by using that formula, it will becomes n plus k minus 1 c n. Either this formula or this formula you can apply. So the number of terms in the expansion of x1 plus x2 plus x3 plus and so on xk power n are n plus k minus 1 c k minus 1, or n plus k minus 1 c n. Similarly, the coefficient of how to calculate the coefficient of this is very important one. Based on this, I will give example also. The coefficient of x1 power n1 into x2 power n2 into x3 power n3 and so on xk power nk in the expansion of x1 plus x2 plus x3 plus and so on xk whole power n, where this is important one, n1 comma n2 comma n3 comma and so on nk are non-negative integers such that n1 plus n2 plus n3 plus and so on nk is equal to n is the coefficient of x1 power n1, x2 power n2, x3 power n3 and so on xk power nk is this one. N factorial divided by n1 factorial into n2 factorial, n3 factorial and so on nk factorial. After that, what we have to do is, in place of x1, x2, x3, you can keep that 1. So 1 power anything. Anyway, it will become as 1. So no need to write anything this. It will come in example, I will explain. I hope these two will be. But whatever I kept here, star marks, based on this, we may expect the questions in the JEE means, especially in advance. And important note regarding this. This note is, if n1 plus n2 plus n3 plus and so on nk is equal to, is greater than or less than, observe carefully ma, this is greater than, this is less than, or less than or greater than n, then the coefficient of x power n, the coefficient of not only x power n now here, the coefficient of complete term, the coefficient of x1 power n1 into x2 power n2 into x3 power n3 into and so on xk power nk is equal to 0. Observe carefully. If n1 plus n2 plus n3 plus and so on nk is greater than n or less than n, the coefficient of that value goes to be 0. Clearly we can say that. Whenever only equal to n, the sum of n1, n1, n2, n3 and so on nk is equal to n, then only the answer will be equal to n factorial by n1 factorial, n2 factorial and so on. Otherwise, greater than, less than means the answer is goes to be 0. Yeah, we'll discuss one question based on this. Like example only we can consider. The coefficient of x power 3 y power 4 z square into t power 5 in the expansion of x minus y plus z minus t whole power 14 is, so like integer type question, we may expect this type of problem. I hope you are able to understand, your students. I will give that explanation for this. This is equal to n is equal to n1 plus n2 plus n3 plus and so on case. Given expansion in the objective, no need that multiple choice questions, no need of explanation. For understanding purpose I am giving here. Given expansion x minus y plus z minus t whole power 14, here we observe that the sum of the powers of x, y, z and t is equal to the power of expansion here. So 3 plus 4 plus 2 plus 5, which is equal to 14. So whenever n1 plus n2 plus n3 plus and so on nk is equal to n, so we can write as hence the coefficient of x power 3 y power 4 z square into t power 5 is t power 5 in the expansion is in the given expansion x minus y plus z minus t whole power 14 is n factorial, that means 14 factorial divided by n1 means 3, n2 factorial, that means 4 factorial, n3 factorial, 2 factorial, next n5 n3 n4 is 5 factorial. After that x1 power, so x1 power, x1 value is 1 only here, so x coefficient, x in place of x substitute 1 power, here 3, x2 power n2, x2 value is what here, minus y, minus 1, minus y coefficient is minus 1, so minus 1 whole power n2 means 4 into, here z coefficient is 1 power 2, next t coefficient is minus 1 whole power 5, so which is equal to, ultimately this will become minus, so minus 14 factorial divided by 3 factorial into 4 factorial into 2 factorial into 5 factorial. This is the coefficient of x power 3, y power 4, z square into t power 5 in the expansion x minus y plus z minus t whole power 14. I hope you understand that. In place of x, y, z, t, in the next question, x, y, y, z, z, x is there, and the power of the expansion is not equal to the sum of the powers of x, y, z. So that time how to do that? That we will give it. One example, dear students. So another example. Find the coefficient of x power 10, y power 12, z power 8 in the expansion of xy plus yz plus zx whole power 15 is so how to do this? First what we have to write is given expansion is xy plus yz plus zx whole power 15, and here we observe that the sum of the powers 10 plus 12 plus 8 is equal to 30. So here the expansion is whole power, n value is 15 only now. But how it will be? 10 plus. But here I want only n1 plus n2 plus n3 value is equal to 15 only now. I want. So how it will be? So the powers of x also that will be changed. So x1 power n1, x2 power n2, like this it will be there now. So how we will get it? See, and that expansion xy power xy plus yz plus zx whole power 15 can be expressed as, generally what we will write, sigma or summation 15 factorial by n1 factorial means 10 factorial n1. We don't know that n1 into n3 values, so the values are given. 10 plus 12 plus 8 is equal to 30 we wrote. So here n is equal to 15 only now, but how we will get it is n is equal to 15, for what values are suitable, that I am going to see that. So n1 factorial, we don't know that n1 value, n2 factorial, n3 factorial, x1, in place of x1 what value is there? Xy is there, xy power n1. x2, in place of x2 yz is there, yz power n2. In place of x3 zx is there, x3 power n3. That is equal to sigma 15 factorial divided by n1 factorial, n2 factorial, n3 factorial. Here x power n1, y power n1, y power n2, z power n2, z power n3, x power n3, sigma 15 factorial by n1 factorial into n2 factorial into n3 factorial. Bases or equal power should be added. See, from these two, from these two, from these two. So we will write it as x power n1 plus n3, y power n1 plus n2, z power n2 plus n3. I hope you understand that. So where n1 comma n2 comma n3 are non-zero, non-negative, that means non-negative integers such that n1 plus n2 plus n3 is equal to 15 according to the multinomial procedure, and the power n should be equal to n1 plus n2 plus n3 only, no? So for the coefficient of, this is important step, observe carefully, for the coefficient of x power 10, y power 12, z power 8, we must have, so that means the power of x here n1 plus n3 in this. So it should be equal to n1 plus n3 is equal to 10. In the same way, y power here n1 plus n2, here y power is 12. Here n2 plus n3, here power is 8. So we must have n1 plus n3 is equal to 10, n1 plus n2 is equal to 12, n2 plus n3 is equal to 8. Now simultaneously solve these values. So I am solving these first and last. n1 plus n3 is equal to 10, n1 n2 plus n3 is equal to 8. By subtracting sign change, these two will be cancelled. n1 minus n2 is equal to 2. So here n1 plus n2 is there now already. So n1 plus n2 is equal to 12. Adding these two, here we subtracted. So 2n1 is equal to 14, n1 is equal to 7. So n1 is equal to 7, that implies that n1 plus n2 is equal to 12. Substitute in this. 7 plus n2 is equal to 12. That implies n2 is equal to 5. 12 minus 7. n2 value we got it. Next, n2 is equal to 5. That implies that n2 plus n3 is equal to 8. That implies 5 plus n3 is equal to 8. That implies n3 is equal to 8 minus 5, that is equal to 3. Now you verify n1 plus n2 plus n3, is it equal to n or not? Absolutely equal here. So here n1, now come to they are asking the coefficient of, no? So therefore the coefficient of x power 10, y power 12 and z power 8 is, in the expansion, that we have to write it, in the expansion, of xy plus yz plus zx whole power 15 is equal to, or simply write it, is 15 factorial by, in place of n1, 7 factorial, n2, 5 factorial, n3, 3 factorial. Next, Here xyz values always you write it as y because whenever they are asking to calculate that x1 x2 values xyz values always 1 only. Suppose in place of that all plus is there means plus x coefficient is positive plus y coefficient is negative, suppose y minus you take. Similarly in this expansion all plus only, no, so 1 power 7, 1 power 5, 1 power 3, so that is equal to 15 factorial by 7 factorial into 5 factorial into 3 factorial. This is the way. Whenever the power of the expansion is not equal to the sum of the powers of given coefficient, we can do in that way. So once again I will revise the question. These type of questions they will ask in the JEE. We can do by practicing, it will be easy. JEE models questions, these are JEE model questions, JEE model and advanced also, advanced model. We will move to the next question. One more example I will give it by taking possibilities. Why every time only x, y, z in terms of x coefficient, the type of question. Another example we will discuss. Find the coefficient of x power 4 in the expansion of 2 minus x plus 3x square whole power 6. This is the question. So how we will find the coefficient of x power 4 in the expansion of the power is 4 here. Here expansion power is 6. So first given expansion and the working you should write given expansion as is the procedure of multinomial theorem. Given expansion 2 minus x plus 3x square whole power 6. So therefore 2 minus x plus 3x square whole power 6 can be written as sigma. According to this expansion n is equal to 6 only, no? So 6 factorial by how many terms it contains? 3 are there. We don't know n1, n2, n3 values. n1 factorial, n2 factorial, n3 factorial. After that, in place of x, in place of y, in place of z, what values are there? That you can write it. So first in place of x2 is that 2 power n1. In place of y, minus x is there. So minus x whole power n2. In place of z or z only, 3x square is there, that to positive. 3x square whole power n3. Okay. So now sigma 6 factorial divided by n1 factorial, n2 factorial, n3 factorial, 2 power n1 minus 1 whole power n, minus 1 whole power n2, x power n2, 3 power n3 into x power 2 n3. So base or equal power should be added. So this expansion will comes sigma 6 factorial by n1 factorial into n2 factorial into n3 factorial. First you write minus 1 whole power n2, 2 power n1 into 3 power n3. So here bases are equal, no, power should be added. So x power n2 plus 2n3. Now n is equal to the sum of these powers. So where n1 plus n2 plus n3 is equal to 6. These powers only know the powers. So for the coefficient of, we need to calculate the coefficient of x power 4. For the coefficient of x power 4 in the expansion in 2 minus x plus 3x square whole power 6, we must have the possibilities. I am saying we must have anyway 2 power n1, 3 power n3 minus 1 whole power n2, which are constants. So n2 plus 2n3 should be equal to 4. So to satisfy this condition, n2 plus 2n3 is equal to 4, but n1 is also there, no. So we need to take a small rough figure. That means the combinations, different combination I am saying here. Different combinations. See how it will comes n1, n2, n3. So what are the possibilities we are going to get? That I will explain. Anyway, n1, suppose one condition we have here, n1 plus n2 plus n3 is equal to 6. To satisfy both the equations, we need to get it and solve n1 plus n2 plus n3 is equal to 6 and n2 plus 2n3 is equal to 4. First we will solve it. After that we will get that different values of n and n1, n2, n3. So solving these equations, n1 plus n2 plus n3 is equal to 6. n2 plus 2n3 is equal to 4. Now I am subtracting one equation from other. So n1, these two will be cancelled. So n3 minus 2n3 is minus n3 is equal to 6 minus 4 is 2. So here n1 minus n3 is equal to 2. Even this is also another equation we have. So based on these three, we will see that what are the possibilities we will get it. So if you take n is equal to, so ultimately the power should be equal to 6 only. So by combinations, different combination, n1 is equal to suppose 4 if you take, n1 4 if you substitute in this last equation, n3 should be equal to what? 4 minus 2. So 2 only will come. So obviously n2 value 0. Like this, n1 if you take as 3, and here the condition n3 should be less than or equal to 2. Sir, why sir we are saying that n3 should be less than or equal to 2 means n3 value is less than or equal to 3 means here the power of 3x square whole power n3 is there. That is the reason it should be less than or equal to 2. n3 always 2, 0, 1 only you can take possibilities. So n1 if you take as 3, 3 minus 2 is equal to 1. So n3 value will become as 1. So obviously to satisfy n1 plus n2 plus n3 value, what is n2? n1 3, n3 is 1, 3 plus 1 4, 4 we can take this side. So n2 value is 2 obviously. So this is another possibility. This is case 1. This is case 2. Case 3 also will come. Suppose if you are taking n1 as 2, n1 is equal to 2. So n3 value obviously 0. So n3 0 if you substitute, 2 plus n2 plus 0 equal to 6 means n2 is equal to 4 only. No? So how we are going to write these possibilities, these three cases in this finding the coefficient of x power 4? Observe carefully. I will show that. The coefficient of x power 4 in the expansion of 2 minus x plus 3x square whole power 6 is, so generally n factorial by n1 factorial into n2 factorial. No, n factorial, that means 6 factorial by n1 factorial. Here first case I am taking 4 factorial into 0 factorial into 2 factorial, first case. Observe carefully, ma. And these n1 into n3 values substitute in this power minus 1 whole power n2. So 2 power 4 into minus 1 whole power 0 and 3 power 2 plus x is equal to 1 we are taking generally here. Now second case, case 2 n1 into n3 value substituting. 6 factorial by 3 factorial into 2 factorial into 1 factorial. So 2 power 3 minus 1 whole power 2. So 3 power 1. Go to the third case possibilities. 6 factorial by 2 factorial into 4 factorial into 0 factorial. So 2 power 2 minus 1 whole power 4 into 3 power 0. Now, if you add these values, it will come answer. So anyway, 6 factorial by 0 factorial is 1. So 4 factorial into 2 factorial. 2 power 4, 16 into 3 square is 9. Minus 1 whole power 0 is 1. No need to write it. So 6 factorial by, here I want to take common 4 factorial and into 2 factorial. So here 3 factorial is there now. So multiplying and dividing by 4. So 4 factorial, sorry, not 4 only. After that 4 into 3 factorial into 2 factorial into 1 factorial is there, of course. 2 power 3 is 8. Minus 1 whole square is plus 1. 3 power 1 is 8 into 3. Plus 6 factorial by 4 factorial, 0 factorial is 1. 4 factorial into 2 factorial. In the next step, 4 into 3 factorial. N into n minus 1 factorial is n factorial. So 2 square is 4. Minus 1 whole power 4 is 1. 3 power 0 is also 1. So 6 factorial by 4 factorial into 2 factorial. 16 into 9, 144. Plus 6 factorial by 4 into 3 factorial is 4 factorial into 2 factorial. 1 factorial is 1 only. So 8 3s are 24. 24 4s are 96. Plus 6 factorial by 4 factorial into 2 factorial into 4. So now take common 6 factorial by 4 factorial into 2 factorial. 144 plus 96 plus 4, which is equal to 6 factorial divided by 4 factorial into 2 factorial. This value is 96 plus 4, 100, 100 plus 144 is 244. 6 factorial divided by 4 factorial into 2 factorial means 2 into 244. 2 ones are 2 122s. So 6 factorial means 720 by 4 factorial means 24 into 122. So 24 3s are, so 30. 30 into 122. So 30 into 122 means 3660. This is the way you can do, dear students. This is like advanced question only. This is just I am showing how the questions are twisting in the binomial theorem. I hope you understand. Any doubts are there regarding this, you can write to my comment box. Multinomial theorem, this is exclusive JEE mains and advanced question only. This is, these are the possibilities. This is also very important selection. Keep in mind that to get n plus 1, n1 plus n2 plus n3 is equal to 6. By taking these as the possibilities and n3 is less than or equal to 2, we can take it. Okay. Thank you all of you. Signing off, Maths with Phaneendrara.